shift. It's just a demand shift. No supply shift. What is going to happen here is bus is substitute to car. So when the bus ticket price goes up, the car demand goes up. That means gasoline demand will go up. Right? That's a higher demand for gas. Then the price will go up and supply will rise with it, but that is not a supply shift. It's just a movement along the supply curve due to demand shift. Make sense? Right? It's not a supply shift, demand shift. You eventually end up producing more, but not a shift. Movement along is the real. Right? Okay. A large decrease in the price of bread will cause demand to shift to the right, left, no shift. Which is the answer? This is butter. That's the price. What will a large decrease in the price of bread do to demand for butter? Yeah.
Increase the demand.
Increase. So you say right shift. Like this?
Yeah.
Yes, because bread and butter are complement. So the price of butter goes down, demand for both will go up. That's a right shift in the demand. Make sense? That is correct. Third one. That is demand and supply of egg. And new article suggests that excessive egg consumption is harmful due to cholesterol. The egg is yellow because of cholesterol, right? That's the reason it's yellow. So some people say that's a bad cholesterol, some people say it's a good cholesterol, but it's cholesterol, right? A new article suggests that's a bad one. What will that do? Will it shift to right, left, or no shift? Which one is the answer? Yeah?
No shift.
No shift, because that is not change in the production structure, that is change in demand. Demand for egg falls, demand for egg falls, the price falls, and the supply falls, but there's a movement along, not a shift. Right? Okay. That's number one. Number two. The information given is this: the Apple Watch demand has gone up substantially, but the price has remained more or less the same. So the price is the same, but demand, the number sold has increased. That is your original equilibrium. What kind of a shift moves you to this equilibrium? Because the information says the price is the same. The quantity has increased. How can you move from here to here? There's just one way for that to happen. Yeah.
Increased income?
Well, both demand and supply should move out more or less at the same rate. Otherwise, you're not going to get the same price. Make sense? The only way you get from this point to this point is for demand and supply to shift out more or less at the same rate. Make sense? There's no second way. So we know demand has gone up. We know demand has gone up. Supply has gone up. We know that based on the information given. Make sense? Otherwise, you're not going to get the same price, more quantity. Does that make sense? Okay. Now I want to identify forces that has contributed to higher demand or supply. What's the role of technology? What has technological improvement done? That has that too. Or supply. So Other technology meant passive supply shock. That has that too. That's one. We know demand has shifted out. Give me some reasons for it. The demand has shifted out. There's no other way you get the outcome without more demand. So give me a potential shift in the demand. What was that? Give me a potential shift in demand. Yeah?
An increase in consumer taste.
Taste?
Increase in taste, like more people want it.
More fashionable. People think it's trendy. Or people think it has some type of use. Some people use it for health. Some people use it to show off. Some people use it to check the time, I guess. I don't know. I'm not into this stuff. I don't know why people have it. But some people have it because it's nice. It looks ugly though. Is it nice? It looks ugly. It's nice? I think it's ugly. It's a taste, right? I think it's ugly. Anyway, I know someone who had a Rolex. I did not know Rolex. So I see a giant watch in his hand, right? And I told him, this is so heavy. Why do you wear it? He said, this is Rolex. I said, so what? And he said, this is $10,000 Rolex. I said, so what? He said, no, this survives 100 meters under the sea. And I told him, you've never been there, you never go there. It's weird. It's fashion, right? People think everyone's watching, but no one is watching. No, I've never noticed that's a Rolex. I've seen it a million times. I just thought this guy's crazy. Having a giant watch, not needed, on his hand. Why do you want to have it? It's so heavy, right? Anyway, but it's fashion. It's fashion. The same with iWatch. I think it's a fashion more than anything. It's a statement, not functionality. Okay, what else? What else outside taste? More money. People have more money. Apple Watch definitely is a normal good. More money means more demand. Those are primary factors for more demand. More functionality, more taste. People think they need it for whatever reason it is. But people have more money. Right? Okay. That is item number 2. 3. The price of component has gone up. What do you think the role of that has been in the shift of the demand and supply? The price of component has gone up during that time. What's the impact of that?
Supply goes down.
Yeah, so that is typically what happens. You have forces fighting each other. This says lower demand, this is higher demand. You know demand is up, so the first force here is stronger. You know that. You know the force of technological change has been stronger than the force of higher price components. Because you know the supply has gone up. Right? You know in the meantime that the price of phone has gone up. What's the impact of that one? The phone price has gone up within that time. Apple phone used to be like 700. How much is it now? 2,000? I remember when it became 1,000, people said the demand would fall off the cliff, right? Never happened, right? Like 2,000 now. They all look the same, right? They all look the same. 14, 15, they're all the same. Anyway, what's the role of increasing the price of phone? Anyone? Everything equal. The price of phone goes up. What happened to demand or supply of Apple Watch? Phone and watch are complement. So higher phone price means lower demand for phone. But you know overall demand has gone up. So this must be much stronger than this one. So that's what happened in the real world. The one that's not really predictable is this one. The demand is so hard to predict because how do you know how taste will change, right? Otherwise supply is easy to figure out. Other factors are sort of easy to figure out. But demand becomes very hard to figure out because of this one. I can't even use the pen. My pen ran out of ink. What should I do? Need an order. Okay. That is Microsoft. I hate Microsoft. worst thing that happened to the world is Microsoft monopoly. And then Apple monopoly. I can't use it now. See, when this happened, that means the battery is dying. So I should recharge it for a second. I think it's not the battery, I think it's just the system. And then it works. Okay, next one. The price elasticity of supply is higher in the long run compared to the short run. True, false, maybe, or sometimes. Which one? Is it always true, always false, or sometimes? It says supply in the long run is more elastic than the short run. Is it always true, always false, or depends? That is always true, as we just had. Supply is always easier to adjust in the long run. The issue was the short run, whether it's vertical or not, but the long run is always more elastic. It doesn't depend on anything. It's always the case. What about the second one? The price elastic demand is smaller in the long run versus short run. Is that true, false, or sometimes? Can you say long run demand is always less elastic than short run demand? Is it true, false, or it depends? It depends. If you recall, demand, sometimes more elastic long run, sometimes less elastic long run. Depends on the good. So give me an example for this case where the long run is less elastic than the short run. Anything that's not daily necessity, stuff you don't have to buy every day. So TV, I don't know, car, stuff like that. Anything that you have to buy every day in the short run, very elastic, in the long run, more elastic. Anything otherwise, go this way. More elastic, short run versus long run, that's sort of TV and stuff like that. Sometimes the example is TV. Next one. The price elasticity of demand for New Balance, a brand of shoes, is less than that for equivalent generic shoes. True or false? Can you say New Balance shoes demand is less elastic than equivalent no brand? Say Walmart shoes, yes or no? True, false, or sometimes? That is true. Anything that has a brand recognition, that's less elastic. That's the reason, in fact, why companies advertise. They create brand recognition, the demand elasticity becomes low, then they can jack up the price. Right? You create attachment. You create attachment, that makes it less elastic. People are willing to pay anything for it then. Right? Make sense? That is true. That's the reason, say, some people pay $2,000 buying shoes. Why pay $2,000 buying shoes? Someone told me Balenciaga is $2,000. Why pay $2,000 buying shoes? It's not like it's lasts forever. You're not going to wear shoes forever, right? Nobody does that. You buy it because it's a brand recognition. Right? Anytime you have a brand recognition, demand becomes very less elastic, then you can just keep increasing the price. You don't lose much demand. Right? That is true. This is, I haven't talked about much, but see if you can figure it out. Demand for dishwasher is short-run income elastic, meaning when your income changes, the demand for this one changes by even more. If your income goes up by 2%, demand for dishwasher goes up by more than 2%. That's income elastic. True or false? You think dishwasher is short-run income elastic? No? Okay. Suppose you find a new job. get a good pay, what is the first you buy? You buy a car, home, furniture, TV, dishwasher. You're not gonna buy more hamburgers, right? As a result, this stuff are called big items, cyclicals, because they are very short-run, income elastic. They react to income change right away. Means that's the way we behave. All right, if the income changes, you're gonna go to buy stuff that hard to get, lasts longer. Dishwasher is one of them. Anyway, at the aggregate level, income is just GDP. So they react to GDP change. When GDP goes up by 1%, demand for those go up by more than 1%. When GDP goes down, the demand for them go even by more. As a result, they call them cyclical. They react to economic cycle. They call them cyclicals as well. Give me a store that sells cyclicals. What is a store that just sells cyclicals? Doesn't sell anything else. Just sells stuff that lasts long. That's Best Buy, right? They just sell cyclicals. Is it TVs? I don't know, fridge, electronic stuff. Those are cyclicals, all of them. So check Best Buy. If they do well economically, the economy is doing well. Because they sell cyclical stuff. If the economy is doing well, they do even better. If the economy goes down, they do even worse. Make sense? So quite often, if you are in the stock market, you check what Best Buy does. That tells you how the economy is doing. Right? Make sense? Anyway, this is though true. This is true. Last conceptual one. Precious metals are needed for nothing except for jewelry. Why are they so expensive then? Say ruby, they have no use. It's just nice. So there's some, is it nice? Ruby is nice, I think. Ruby is nice. The red one is nice. They have no use though. It's just jewelry, right? The demand is so low yet the price is so high. Why? Because the price is not the demand, is not the supply, it's both of them. So low demand may be accompanied by even lower supply. You're going to end up with high price. That's what it is here. Low supply. So quite often, suppliers artificially reduce supply. Say in the old days, it used to be diamond industry destroyed diamond. Or you held them. They didn't sell them to jack up the price. Or say, whoever created Bitcoin made 20 million. They could have made 20 trillion. It's just a computer program, right? Just add zeros. Why they did 20 million? Because you create artificial shortage. Then if you somehow create a supply, the price will go up to 100,000. Make sense? That's what it is. Anyway. You know they say Rolex says it's so hard to make those watches. That's the reason it's so expensive. It's not true. You can hire people making those watches easy. You can automate the whole thing, right? That's artificial shortage. Then there's attachment to it, and you create very high price. Someone is willing to pay 10,000 for it. Crazy, right? That someone paid 10,000 for a second-hand watch. I'm not going to pay 10,000 pennies for it. You have to pay me to wear it. But someone paid 10,000 bucks for a second-hand watch that survives 100 meters under the sea. The whole thing's ridiculous. Anyway, it's a taste, right? People have different tastes. Everyone is different. Demand for canola oil is highly inelastic. That's the demand. Highly vertical-ish. Not exactly vertical because there are alternatives to it. It's highly elastic. How would the supply looks like for canola in the short run? It will be perfectly vertical because it's food. You can't recycle it. You cannot recycle it. In the short run, the supply is set until next season. That's the demand and supply in the short run. What happens if there is drought in Canada, which is one of the biggest producers. You have a small change in the supply and big change in the price. So these commodities, agriculture products, the price is very volatile because demand is highly inelastic, supply is infinitely inelastic. So small change in the supply either way leads to a big change in the price. If the supply is disrupted by 2%, sometimes the price doubles. So since the price is so volatile, often when they report inflation, they ignore it, they cancel it out. They report the inflation, they call it core inflation, which exclude food and gasoline, because the price is so volatile. They react to short-term change in supply, react to drought, stuff like that, right? You cancel it out, they report what they call core inflation, right? Anyway, you know, years ago, a couple of years ago, when the war in Ukraine started, they estimated the supply of wheat might be disrupted by 10 million tons. You know what 10 million tons is? It's 1% of world production. That's how much it is. That's how little it is. The world production is a trillion. It's just 10 million. It's nothing. It's 1%. The price doubled. That's the reaction. Because the demand is so inelastic, and the supply is infinitely inelastic. You have to wait a year before you compensate for it. And as a result, the price will really react. Anyway, so the answer is the price will dramatically increase. Supply of zinc is which one? This one or this one? Which one is shorter on supply of zinc? One or two? Is it one or two? Is zinc like canola? It's not. You can recycle it. Since you can recycle it, the supply is not vertical. It's verticalish, but not vertical, because you can always do production through recycling in the short. Right? So the supply is highly elastic, but not infinitely inelastic. Alright? Make sense? Okay. Anyway, we're done with the concept. Let's go to the calculation. If you have demand and supply, you should be able to do demand and supply analysis. But how do you get the demand and supply? The answer is very hard to get them, unless you make a simplifying assumption. Number one, you make an assumption that demand and supply are linear. If you don't make that assumption, very hard to get the demand and supply. You need complex calculation. So let's make that assumption. Demand and supply are linear. If you make that assumption, then the only thing you need to find the demand and supply is equilibrium price quantity. That's readily available because you can see that at any point in time. You know the price, you know the quantity. Beyond that one, you need the elasticities, which can easily be found as well. So a little information which is handily available allow you to estimate demand and supply if you assume linearity. So that's the main assumption. Alright? So here when you assume linearity, the information given will allow us to estimate demand and supply. Then we should be able to do demand and supply analysis. This is the cheapest pointer I've seen. And it's in every room. They don't last at all, and it's terrible. Buy something better. Alright? What is this? Like ridiculous, right? Anyway, I drop them every class I go. I have broken all of them. Last term, this is the new version of it. Anyway, to the number we go. We want to do demand supply analysis. We want to see what will happen if the government initiate $50 in tax, sorry, in subsidy. Alright? For that, we need demand and supply. We made the assumption linearity. We have the equilibrium. that is 1,000. Let me write it here. That is 400. And we have the elasticities. That should be good enough to estimate demand and supply and do demand and supply analysis. Alright? There are two ways to do it. I will show you both ways, but I'll give you a simple rule of thumb. If the shock policy, tax or subsidy, you will need the inverse demand, inverse supply to apply it, to fund it directly. So when you write the formula for linear demand, write the inverse demand, inverse supply. Don't write the actual, because then you have to flip it at the end to apply the shock. So write the inverse demand, like this one, then try to find the parameters of it. See, I wrote the inverse, not the actual. Then I tried to find A, B, C, D. I did not write Q as a function of P. I wrote P as a function of Q. Why? Because to apply the shock, I will show later on, we need the inverse. Right? Then try to find A, B, C, D. I quantify the demand and supply, then try to apply the shock. Right? Okay. This is what we have for the elasticity of demand. The elasticity of demand, which is minus 0.8, that is equal to slope of demand function and price quantity ratio. Make sense? We have the price quantity ratio because we have the price and quantity. That is 1,000. 400. We don't have the slope, but we have the whole thing. Make sense? Okay. Based on the way I wrote the inverse demand, what would be the notation for the slope? What should I put there? Should I put A, B, C, D, or a function of those? I need this one. The first derivative of the demand function. Use this one and give me the number. Well, not the number, the notation for it. What do you get? Is it A, B, C, D? What is it? Well, I wrote the inverse demand, so I have this one. That is how much? Minus B. So what should I put there? B? How much? See, the way I wrote it, I wrote the inverse demand. I have the slope of the inverse demand. That's minus B. I need the slope of the actual demand. That should be minus 1 over, it's the inverse of it, right? That should be minus 1 over B. Right? So I wrote the inverse demand, not the actual demand. So if I want to fill up for that one, I have to put the inverse. Right? Make sense? Then I can find B. How much is B? What is B? What's 1,000 divided by 320? 3 pounds? 3 pounds? Someone with a calculator. What's 1,000 divided by 320? I'm going to do the other side of it soon. Yep.
3.125.
3.125. Now that is 3.24125. That is 400. The price though is 1,000. That allows us to find A. How much is A then? A should be 1,000 plus 3.125 multiplied by 400. That sounds like 1,250, right? So it should be 2,250, am I right? A should be, how much is A? 2250? 2250. So my demand should look like this one. So by demand I mean inverse demand. I found the inverse demand. Do you make sense? I found the intercept, sorry, I found the slope. I have a point on the demand, I can find the intercept, which I did. Fine? I found the slope, I put it there, I have Q, I have P, I found it. Okay? Okay. I'll do the same thing for the supply. That is 2. Is it 2? Yes. I need the slope of supply function. Price quantity is the same. What's the slope of supply function? That's the inverse supply. That's the slope of it. So what should I put there? 1 over D. That's 1 over D. So D should be how much? 1,000 divided by 800, which is 1.25. Right? Yes, 1.25. So I'll go back here and say this is 1.25. This is 400. I don't have C yet, but this is 1,000. So how much would be C? That sounds like 500, right? 500? 500. That should be the supply then. I find the demand. Inverse demand, inverse supply. Alright? Make sense? Yes? Okay. Now the reason I found the inverse, because if I want to apply the shock, which is $50 in subsidy, I need the inverse. That's the reason I did it. If I find the actual demand, actual supply, then I have to flip it to get the inverse. This saved me a step. So the reason I did it because I want to apply the shock. This is what subsidy does. Subsidy makes the price. Consumer says, pays less than what producer gets by $50. If you have a subsidy, the consumer pays less than what producer gets. Because the government pays the subsidy. Make sense? I have to apply this to get the new equilibrium. That's number one. Number two, as always, demand and supply should be equal. If I somehow apply these two equations together, I will get post-subsidy equilibrium. Make sense? And to apply them, I need the inverse demand, inverse supply. Right? Okay. So let me apply them. That is PD, that is what the consumer pays. That's PD equal to PS that is PS minus 50, that's minus the subsidy. That is equation number one. Apply. PD, that's PD, that's PS, that's 50. Right? Equation number two says the quantities are the same, so I'm going to lift the subscript because they're the same. That applies both equations. That will give you post-subsidy equilibrium. Right? So I need that Q. I'll graph it, show you what I'm doing in the graph, but I need that number. That was the initial demand and supply. That was the quantity. That was the price. I'm trying to find an equilibrium somewhere there where the price consumer pays is lower than what producer gets by 50 bucks. You're trying to find this number. That's the Q. If you solve it, that's what you're finding. A quantity where consumer pays 50 bucks less than producer. So it will be more than 400. I know it's more than 400. How much is it? If you solve it, based on the graph, it will be more than 400. How much do you get? Anyone? I need that number. I know it's more than 400, but I need how much do you get? Yeah?
I got 411.43.
Just round it, it's fine. 411? Now take this one, put it in a demand. In the real world, what consumer pays is the equilibrium price. So find PD, that's the equilibrium price in the market. I know the producer gets 50 bucks less, but in the market, always what the consumer pays, that's always the equilibrium price. So take 411, put it there. That gives you this one. That's the equivalent price in the market. How much is it? It will be less than 1,000. That's what the graph says. How much do you get? 900? 900? 60? Somewhere there?
Yeah, like 96.
96. Just rounded. 965 or 6?
966.
And the producer gets 50 bucks more. That will be 1,060. You finished? Make sense? I know people say, I don't know where this comes from. They always ask who the subsidy goes to. Does the producer get it? Consumer gets it? That's completely irrelevant. It doesn't do anything. You always get the same outcome. You can have it two ways. You can say the subsidy goes to producer, then that will be considered as supply shock. That's one way of looking at it. Or you can say the subsidy goes to consumer, that would be a demand shock. It doesn't really matter. You end up with the same outcome. Make sense? Whether the consumer gets it, producer gets it, that's completely irrelevant. The outcome is always the same. That's what we solve. So for us, we don't look at the subsidy as a shift. It's irrelevant. Then you have to say who gets it, which doesn't do anything. It does not change the outcome. So we don't shift the demand, we don't shift the supply. We just find the outcome, which is always the same. Make sense? Do they say supply shift? I think in some courses they say that subsidy is a supply shift, right? It can be a demand shift if you give the subsidy to the consumer, right? But the outcome is the same. You're gonna end up with the same outcome, which is 411 sold, consumer pays 966, producer gets 1,060. Make sense? Okay. Anyway, that is one. I'm gonna do a different version of this one soon. Well, that's nice. Next one, here I gave you demand and supply. So you don't have to find it. You just have to find the elasticities. I gave you demand and supply. You try to find the elasticity at the equilibrium. So for that you need the equilibrium. Both of them equal, find the price. What's the equilibrium price? 1900 divided by 250. How much is that? That's the equivalent price. 1900 divided by 250. What do you get? So if you put them equal, that would be 1900, that would be 250. What's 1900 divided by 250?
7.6.
7.7?
0.6.
7.6. So that would be 1060, I guess, right? Because if you use this one, you get 1060. That's the equilibrium. Now we try to find the elasticity of demand in the equilibrium. We need the slope of demand function because the price quantity is already found. What's the slope of demand function? What should I put there? That is the slope of demand function. Alright, that is minus 150. That gives me elasticity of demand. Alright? For the supply, the equilibrium is the same. But there I put the slope of supply function. Alright? And that will give me elasticity of demand and supply at the equilibrium, which is this point. How much is ED? How much is the elasticity of demand? How much is this one? Minus 1 pound?
1.4.
Like this? The demand is slightly elastic, slightly more than normal. Make sense? That's the demand elasticity. What about this one? This looks much smaller. This is 50% smaller than this one. In absolute term, how much do you get there? 0.7? 6. The supply is fairly inelastic. It basically means in equilibrium, if you change the price by 1%, demand falls by more than 1%. Supply rises by less than 1%. That's what it means. At this point. Elsewhere it changes. But in equilibrium, demand is slightly elastic, supply is fairly inelastic. Make sense? Okay. Okay? Okay. Next one is 5. Both the same, I change the numbers. But, see the shock? You have demand rising by 25%. That's the shock. It's not tax or subsidy, it's a change in demand. So, we need the new demand. We have the old one, if you found it. Based on the information given, what would be the new demand as a function of the old demand? The question says the demand has risen by 25%. So what's the multiple? What's the multiple? The question says you have demand, now you have a new one. The new one has gone up by 25%. So what's the new one as a function of the old one? 1.25, right? See, to analyze the shock, I need the actual demand. I don't need the inverse one. So here, I'm going to solve for the actual demand and supply. I don't need the inverse. The inverse is only needed when you apply tax or subsidy. You need the P and TSPD. Here you don't need it. You need actual demand, actual supply. So write it and solve it directly. Otherwise, if you do it the way we did before, you have to fill it at the end. Make sense? That is my actual demand. That is my actual supply. Then I try to find the boundaries. Make sense? So if you don't like me going back and forth between these two, you can just use one and flip it at the end if you require. But if you have tax or subsidy, to save your save time, do the inverse. Anything else, do the actual. Make sense? Okay? Okay. Okay, we want the elasticity of demand. We have it. That is minus 0.4. That is equal to the slope of demand function, price, quantity. We have the price quantity. How much is it? 100? 2800. The whole thing is minus 0.4. What's the slope of demand function? What should I put there based on notation I use there? How much? What should I put there? Minus B, because that's the actual demand. I don't need to reverse it, right? I wrote the actual demand, that's the actual demand. So, make sense? Okay, that is that, and then I found B, which should be 0.4 multiplied by 28. How much is that? 11.2? 11.2? That sounds like it. 11.2, right? Now I say this is 11.2. This is the price, which is 100. This is 2800. How much is C? What is C? 2800 plus 1120. How much is that? It's 3920, right? Alright? 2800 plus this. That sounds like 3920. Right? 3920. Minus 11.2. Right, that is my demand. I found the demand. Right? Do the same thing for the supply. That is 1.8. That's the slope of supply. That is price quantity. What's the slope of supply? What should I put there? That's our supply. I should put D. You're so quiet, you scare me. D, right? That is D. So what would be D? That would be D. What is 1.8 multiplied by 28? 50? And how much? I remember the 50. 50? 4. So I'll do the same thing. This is 50.4, that's the price, which is 100. I don't know C, but the whole thing should add up to 2800. So what would be C? C should be 2800 minus 5040. How much is that? I need C. It should be 2800 minus 5040. Is it minus 2240? Is that right? That's right. So the supply is this one. Don't be scared if the supply has a negative sign. That's often the case. That's not rare. That happens all the time. I'll explain what it means in a bit. The supply can have a negative slope. Sorry, negative intercept. That happens all the time. Make sense? Okay. Let me grab these two. That is quantity, that's the price. The demand looks like this. Supply. The intercept is negative. I know it's either this one or this one. Which one do you think it is? I know there's an intercept. It does not go from the origin. Does it hit the vertical and the horizontal line? Which one? Why the second? If the intercept is negative, what does it mean? It means the price cannot be 0. That's the meaning of it. If the intercept is negative, it means the price cannot go to 0. It's 1, not 2. So if the intercept is negative, it is the vertical line. And the price cannot be 0. That's the meaning of it. That is the way to graph it. If the intercept is negative, it's positive, basically it means the price becomes 0, you still produce something for 0. Make sense? Okay, that's the original case. This is 2800 this is 100. That's where you stand currently. Right? The question says demand has gone up by 25%. So the new demand is 1.25 the old demand, which is this one. That's the new demand. The supply is the same. It hasn't changed. Put this to equal, find the new equilibrium price. That's the new demand. That is the supply, hasn't changed. Put them equal, find the new equilibrium price. I need that number. What would be the new equilibrium price? I know it would be more than 100 because you have a positive demand shock. The demand is shifted out. So I know it would be more than 100. How much is it? What is the new equilibrium price? I know it's more than 100. If you solve it, you will get more than 100. What do you get? It will be more than 100. 110, 111? I'm not sure. Anyone got the number? That's the way I remember it. Is it 111? Do you get 111? That's the new equivalent price. Did anyone verify? I think it's 111. I need a verification though. Did anyone verify? Yes? No. 111. 111. Now give me the equivalent quantity. Take this one, plug it in supply, that's faster. Give me the quantity. It would be more than 2800. How much is that one? I remember 3,300 and change. How much is that? I remember 3,300. I don't know what that is. 3,300. How much?
3354.
Just round it. 335? 4. Okay, now I have to graph it. If I graph the new demand, would it be like this? Would it be like this? That's a parallel shift, or I have to change the slope. Is it parallel, or I have to change the slope? Is this a parallel shift? Of course not. It's not a parallel shift. This is wrong. It's not a parallel shift. The slope changes. A percentage change would change the intercept, would change the slope. That's not a parallel shift. A parallel shift would have been a demand changes by 20 points. 30 is a constant number, which is not the case. So I can't graph it this way. The slope has to change. So now the question becomes, should I make it steeper or flatter? Well, that didn't work. Should I make it steeper or flatter? Which one is it? And you know it's not parallel. Should it look like this or this? Which one? This? Steeper? Sorry, flatter? Or steeper? Which one is it? This one? This one? Which one is the correct one? This one? Flatter. This one? This one? That's steeper. Okay. You missed it both times. It should be flatter. Because that is the actual demand. The slope of actual demand goes up by 25%. That's the inverse demand. When demand becomes steeper, the inverse demand becomes flatter. That's the correct one. If you want to graph it, graph it correctly, you should graph it sort of like this. The slope changes, becomes flatter because the actual demand becomes steeper. Make sense? That gives you nice graph, everything accurate here. although it's not up to scale, obviously. Make sense? Okay. Anyway, I'm gonna give you a hint of how number 8 is done. You should do it on your own. It will show up on your quiz version of it. That's a tax, not subsidy. This is replica of question 5, but tax, not subsidy. Since it's tax, don't do it like question number 7. Don't do the actual, do the inverse. That saves you one step. So write the function this way. That's the inverse demand. Write the supply this way, the inverse version of it. Then you have the demand elasticity, put it equal to the inverse of the slope, because that's the inverse demand. You need the actual. And you have the equilibrium. Solve for B, then solve for A. Make sense? That's for the demand. For the supply, this should be 0.9. That should be 1 over D. That should be the same. So that way you find the demand and supply. Very similar to question number 5. Exactly the same. Then you need to apply the shock, which is tax. The tax will mean the demand consumer pays, a price that includes the tax are either paid more than what producer gets. So subsidy was minus, tax becomes plus. That's your equation number 1. And equation number 2 becomes supply and demand are equal, then you solve for the new equilibrium. Make sense? Okay. So your graph should look like this. That's the old equilibrium, which is 50,000 and 1.5. The new equilibrium is to the left, not to the right. Subsidy pushed you past this point, tax the other side. You will end up with an equilibrium here, where the price consumer pays will be more than what producer gets by how much? By tax, which is 40 cents. Make sense? So it becomes sort of question number 5, just the other side of it. Alright? The reason you do the inverse, because you need the inverse to apply the shock. You do it like question number 7, then you get the actual demand and supply, then you have to flip them to get the inverse. Waste one step. Alright? Graphically speaking, you can think about tax as negative supply shock. That's one way of looking at it. Or you can look at it as negative demand shock. For us, it's irrelevant. Because which one shifts depends on who actually pays it. At the end, you get the same outcome. So we ignore it. We're not going to shift anything. As long as you have this new equilibrium, we're fine. Do I have it backwards? Sorry, I have it backward. One more time. You can look at it as either negative supply shock or negative. Where is my demand? Negative. I have it right. Negative the demand shock. Both will work. Make sense? At the end, though, you get the same quantity, the same price that the consumer pays. It doesn't make any difference. So don't shift the demand, don't shift the supply. The graph looks out. Alright? Make sense? Okay. That is lecture number 1. We're done. Our next lecture, not fun. You don't watch the video, so watch the video. Otherwise, the next 2 lectures, lots of stuff. When I say lots of stuff, there's a lot of stuff.